Hi and welcome to this Rust tutorial here on my channel. The last video, and it was the first video, we looked at, well, basically it was head first approach. We tried different things, we just bounced our head in the editor, used an online editor, which I'm going to continue with today and still for a probably good amount of videos, because I feel that we shouldn't be too confused about other things right now. We should just focus on the language itself, because we can already program. But what about Rust? It's kind of different, right? So today I will do a more structured approach, because last time we just got a feeling of the language and how it felt and the syntax and stuff, and we think it looks pretty much like a something in between, like mostly Java, but I also see something Python-ish to it, because it feels a bit more procedural than object-oriented as for now. So we're going to go ahead and continue with data types. So last time we did talk about data types, but we didn't really explore them in a way. So we have the different kind of data types. We store them in a let variable, right? So we're declaring a variable using the let keyword to declare a variable. Now this reminds me a lot from, JavaScript. Also, Python got this automatically converting variable type. They just put stuff inside of it and it's then magically becoming whatever type you put into it. Of course, this does require a bit of, compile time, runtime. As I understand, it's a compile time language, so it would not really do anything with the runtime because it's already running as the type you declared it to. So we can just basically put, strings and floating types and Boolean types, even Unicode inside of it, and then we can basically print it out with this format declaration that we talked about yesterday, or yesterday, the last video. For me it was yesterday, but for you it's probably the next video that could be any time in time, I guess. So the company string will then be output right there in between, rating float there, and so on. So it will generate this output, and it's pretty nice to know about data types and how it works. We would still like to know about concatenation and how we do, add variables together. This is something we did play around with yesterday, and just by doing head first, and usually that fails when you get to a certain point in time with a language. It kind of fails because you begin to how to do this and that. First time you tried something like Python, for example, if you can do Python, you probably also figured out it was like, you can do this, you can do that, but how do you do this or that, and what is a tuple, and all these kind of different things, right? So this was kind of the data type, and going to the next one called variables right here, and it's called rules for naming a variable must be composed as letters, digits, and underscore characters. It must begin with either letter or underscore. Uppercase, lowercase are distinct because Rust is case sensitive. So that's pretty nice to know that a variable called, for example, fees with a small f and a capitalized F are two distinct variables, and it would seem like we have some syntax declaration for a variable here. So some variable and a value, and we just add a value. So we define the variable without a data type. This is the way, and we can also do a colon defined. So this is the way Rust accepts us to specifically say this is a type of variable. So it can be lit variable, and I guess float, a bool, whatever. And then we put in a value, but then the value has to be of that specific type. That is the deal with case. Type specific languages, right? So we have an illustration right here, and we can see that it does say it will output. I don't have an output here below, but that's the output, I guess. So in Rust, it does say that by default variables are immutable. Read only in Rust. In other words, a variable value cannot be changed when the value is bound to a variable name. So basically means that we cannot give a variable a new value. So let's go ahead and try this. Just in our editor, so we're gonna delete this. Gonna keep that. Go ahead and write let a equal to 1 and let b equal to 2, and then we can go ahead and basically say, and then do a comma and starting and opening, and then say a and comma b, and that should create our string for us right here, saying 1 comma 2. So it was already declared as 1. So if I say a equal to 3 now, and run this code, it should actually say, you cannot do that because it is immutable. So we would need to, and I need to do stuff, and it does actually give us the answer right here. Consider making this binding mute a. I don't know if it means I should do like this. I have no idea. So I make it mutable. I know it doesn't seem like that is the way. So there is something about the mod keyword that would definitely help. Is it supposed to be placed right there? No. So I haven't read it yet. We're just trying stuff. This is also something you should go ahead and try. And I'm pretty sure we will learn this at some point. So it illustrates the actual issue here. So what we could do is variables are mutable by default. Prefix the variable name with the mut keyword to make it mutable. All right, so we should write let mute variable name. So let mute. I cannot. There we go. Let mute variable name equal to 1. And then we should be able to do like the variable name, data type. Let's understand this example. So it does say let mute fees of this type. And then we do like fees now. And this is actually changing the value since we made it mute. So in other words, we should actually get number 3 now. Let's see if the compiler agrees with me. It does. It does have a warning. It's a value assigned to A is never used. And it refers to line number 3. So it is actually true that it's never used. And in this particular case, we could, for example, just output it, and that should actually remove the error. So it does actually give us a really good error message here by telling us, hey, you're having a value and it's not really used. And well, so, okay, so this is an interesting fact that, variables are immutable. You need to declare them with the mod, the mute, whatever they're going to say that, to make it mutable. That's really the way it is. In many ways, I'm pretty sure we're going to learn about constants right now. And I think this kind of could raise discussion about whether normal variables are not already just normal constants, because it's immutable. And constant cannot be changed. But there are different programming situations that require you to create a constant instead of a variable, and that would be whenever you want something to be never ever able to be changed, because there's always a workaround whenever you're working with a language and how to make it mutable. And in this particular case, there's not if you created a constant variable. So you declare an integer of 32 bits, basically meaning you can put numbers inside of it, whole numbers like 100 and 1000 and so on, or you can create a variable called pi as a constant with the type of f32 is a float of 32 bits, so we can create a pretty long number from that. All right. So it does say constant versus variables, and in this section they talk about that the constant declared using the const keyword, while variables using the let keyword. That's pretty easy. A variable declaration can optionally have a data type, whereas a constant declaration must have a data type. So you need to do a data type to a constant, and it's just the way they decided to do this kind of thing in Rust. So I guess this is the way. We also have the one called strings. So, and strings are a little different. They call it a string a literal or a string object. The string literals are used when the value of a string is known at a compile time, and string literals is a set of characters which are hard coded into a variable, for example, company name, tutorial point, and they are found in the module standard. I guess it stands for in the string. String literals are also known for string slices. The following example declares two string literals, companies, and locations. So when we're creating a variable with Rust, using the let keyword defining the actual type of string, then we can do any sort of hard-coded literal value inside of it. And down here it talks about string literals are static by default. This means that the string literal can guarantee to be valid for the duration of the entire program. We can also specify the variable as a static as shown below. And then you do it like this. And this is the weird syntax we're gonna accept from Rust. I think this looks like a syntax error. In all honesty, it looks I react to it pretty heavy. Also because it's gonna become green here down below and say this is a string because it's a normal syntax. But it's just something we have to agree to. The other part is a string object, and it's a type of provided in standard library. Unlike literal, the string object is not a part of the core language. It is defined as a public structure in standard library pub struct string. String is a growable collection. It is mutable and UTF-8 encoded type. The string object can be used to represent string values that are provided at runtime. So they allocated the heap. So to create a string object, we need to use this like format here. So it says like the buff syntax creates an empty string and creates a string with some default value passed from some default value passed as parameter from the from method. Okay, so I wouldn't know there was a method wherever it is the from method. Oh, it's okay, so we should definitely go ahead and test this out. They use this as a way to populate the string object. And we can definitely go ahead and just copy paste this out in our editor. And I should definitely go ahead and try it out. Just run it for first time, see it's working. So length is 0 and length 14. So this is kind of, as a constructor. Can we also put it into new, for example? It doesn't accept that. And this would be a thing that, that's a funky thing, because I think in normal language, whenever you do a creation of an object, you can always put some constructor with a value inside of it. But in this particular case, it seems like we need to use from. So good to know. We learned this right now. And then we have common methods and string objects we can do. Okay, so it kind of explain it right here. We have this weird syntax again, and something that kind of bugs my eye a lot. I must accept it. This looks like horrible syntax. I would say it's a bad choice, Rust team, but anyways. Convert the given value to string. Okay, to string. Replace, push, length, trim. So there's all these different normal kind of string operations. Should definitely have something replacing, and yeah, but with this you can start to create what do you call it? Normal token-based generators where you replace text and censoring stuff, or pulling things out, trimming and stuff like that. That's great. So here we have a illustration where we create a mutable string called C or set equal to string as a new empty string, and we then say push string as a method. So we need to use the push method. We push something on the top of it, it would be, or on the bottom, append, so that would be in the end if the word applies. And then we can, basically go ahead and try this out. Always do these kind of things. So we're gonna run it. It's great. So let's go ahead and do another pile, another run of this. So we say hello. Let's just say hello again. So let's see what we get this time. So now it says hello and hello again. It's been pushed on at the bottom of the string where the word append applies correctly. So this would be pretty great in many ways. Let's see what next. So now they do some naming to string. I'm pretty sure the point of this to access all method convert a string relative object. Okay, so this is just where we take a literal value, which literally it is. That's why it calls it literal value, and then we convert it to the object to string. Okay. And it go through a lot of these methods here. Replace looks pretty standard. I'm not really going to try every single thing. You need to just be aware of whenever something funky shows up, like a weird syntax, you have to try it out to get it. And if you haven't really tried with the ampersands before and this kind of bugs you and when your eyes look at it, you should definitely go ahead and try it out and get familiar with it. That is the only way. Different kind of functions are being used right here, and we just casually go through them just to be patient about it and learning different kind of things, splitting white space. We see nothing crazy here. We can just like for, because now we're actually learning a for loop, so it's for token in. That's kind of the same as in Python, but just with a bit more syntax, delimiters, or what I'm gonna call them, scope identifying characters. So we are getting token 1. So the I is for the I value, so we're incrementing it down here. The token is a variable created on compile time inside the for statement or the for loop. And then we say split on, so we are splitting on white space. So that's a particular function. Is there a function that can actually split on wherever we would like it? String separate. So it would seem we can do a split on a particular character. And this is a good thing to learn, these kind of ways to work with strings. Where was it? It was here, yeah. So we print it out. That's pretty standard. We already know these kind of things. Now we get a bit more funky. We're going to see stuff like vec, and it's it would be, well, it seems like it's a vector, I guess. Yeah, we are splitting it as a vector. And now we're getting well, we haven't really talked about the vectors yet. Why is it mentioning this in the tutorial already? Well, it's just the way it is. But it kind of created assistant. You put strings inside of it as a type, and basically, say full name. The variable is gonna split it. Yeah, there we have the answer for the split. It does accept an argument with a comma. It's great, and it says collect. And the collect is doing something. Maybe we have it up here in the list. We don't. Okay. So now we need to find out what the collect method does. But as we go through this, we're not too particularly concerned about this one function right now. On the chars, it's just gonna split to individual characters. It can be great for walking through legal characters if it's very important you need to do this kind of thing. And concatenation of a string with an operator. So, alright, so it does talk about string concatenation that we talked about before. And we need to do, like, we have the strings and the n1. They're both objects, string objects. If we see, we could be converting it as to string and into references passed. So we're saving this in N3, and it's a little funky. We have an ampersand in front of it. Definitely go ahead and try this out. And run it. And kind of say, the compile playground, bin playground, blah, blah, blah. Mismatch types. Expected. It does kind of expect this. So if you do like a fourth one, tutorial points again, and then we do the ampersand and say plus n4. Would it need it to be referenced also? Okay, so there's something about this in the reference, and I guess it's because that it takes the first one, and we just remove the other ones right here and run it. It kind of just takes the tutorial as the first one and say this is just the value of it. It kind of say warning for unused variables. Let's just ignore that for now. But whenever we are adding more to it, we are adding the reference of the actual string. There are probably ways where we can, do real concatenation in different ways, but I think we should just stick to this way for now. And we can also do typecasting. Which is done by what? Creating a value number 2020 and say new variable again, number string and say number.toString. Is that typecasting? It's just normal conversion, okay, so it's typecasting, I guess, in, yeah, we'll just call it normal conversion. So okay, so I think for this video we're gonna stick for just going through variables and different kind of data types, constants, and also concatenation and a bit of a loop and stuff like that. So I really hope that you did learn something from this video, and if you haven't read already, subscribe to my channel. Please consider clicking the button subscribing to the channel. You will get a notification whenever the video come out, a new video of course, and you will help the channel grow, and I will be much appreciated if you want to help me grow the channel. So alright, so see you again online. Have a really nice day.